Hi everyone, this is Nadia, Assistant Professor, Department of Mathematics, Science and Humanities, Sri Muthukumaran Institute of Technology. Today I am going to discuss with you one of the major topic in applied operation research, which is the subject of one of the subject of first year MBA students. They are going to study in second semester in the regulation 2025. The topic is nothing but transportation problem. So the word is more than enough to understand what we are going to study in that concept. Also, before to study the transportation problem, we want to know what is LPP, that is linear programming problem. That LPP is nothing but mathematical programming technique to optimize performance. That optimization is nothing but either maximizing our profit or minimizing our cost under a set of resource constraints. That constraints all should be a positivity as specified by an organization. So LPP is nothing but we are framing any situation as a mathematical form with three components. So first one is optimization. So second one is the constraints. First one is the objective function. That is, objective function is nothing but either maximizing profit or minimizing cost. Second phenomena is decision variable. It should be all positivity. Third one is a constraints. So these are the three major part of LPP construction. So let's see the what is transportation problem. So transportation problem is to transport different amounts of a single homogeneous product which are initially kept at various origin to different destination with the objective of minimizing the total transportation cost. So in the transportation problem, our objective is minimizing our transportation cost. So through the minimizing cost, we are going to get maximizing the profit. So these are the basic assumptions in the transportation problem. So first one is a very important one. So the total requirement at different destination is equal to the available quantity of the item at various source. Second one, the items can be transported easily from all sources to destination. The cost of the product for unit transportation from all sources to destinations is definitely and exactly known. The cost of transportation on a given route is directly proportional to the number of units transported on that route. Next one, to minimize the total transportation cost for an organization as a whole and not for individual supply and distribution centers is the main objective. The demand of a destination can be satisfied by the use of more than one source. So we have four types of transportation problem I have listed here. The first one is a balanced transportation problem. Second one is unbalanced transportation problem. Third one, minimization transportation problem. Fourth one, maximization transportation problem. So these are the applications in the transportation case. The production planning, inventory control and facility location. So when we solve the transportation problem, we will get a solution. That solution categorized as follows. First one is feasible solution. Second one is basic feasible solution. Third one is optimal solution. Fourth one is non-degenerate basic feasible solution. And fifth one is degenerate basic feasible solution. The fourth and fifth is very important one because whether we are getting the solution. This is the identification to get whether we are getting the correct solution or not. So the checking is we have to check that number of allocation values for that given transportation matrix. It should be equal to m plus n minus 1, where m is the number of rows and n is the number of columns. So m plus n minus 1 is equal to number of allocation, means the solution what we get, that solution is called as a non-degenerate basic feasible solution. Suppose that is less than m plus n minus 1, that is number of allocation is less than m plus n minus 1, we get the degenerate basic feasible solution. So before that we have three more solutions. First one is feasible solution, second one is basic feasible solution, third one optimal solution. So optimal solution is our goal. So we have to in that place we have to set our goal as either maximizing profit or minimizing the cost. So in the transportation problem we have to minimize our transportation cost in the different ways. So we have a few methods to find the solution of transportation problem in two phases. So first phase we are going to get initial basic feasible solution, that is IBFSC for a given transportation matrix. So through three methods. So first one is northwest corner method, second one matrix minimum or least cost method, third one Vogel approximation method or VAM. So the third one is the very important one. So most of the problem is solved by using Vogel approximation method. So through these three method we can get IBFSC only, but we need to get optimum solution for that given transportation matrix. So it's getting by two method. First one is stepping stone method, second one modified distribution method, that is MODI method. This is a very important one. It's playing vital role in transportation problem. So here I am going to discuss with you two method, how to using that method how to get an IBFSC value for the given transportation problem. So first one, let's see what is the how to solve that given transportation matrix through northwest corner method. So we have three steps. So first one is select the cell located at the northwest corner of the transportation table, that is upper left corner of the given transportation table. Second one, allocate the possible minimum value taken either from availability or requirement. Step 3, repeat the process until all the requirements are satisfied. Before we start that procedure, we have to verify whether the given matrix are balanced or not, because whatever method we have to apply to find the solution of transportation matrix, the before first we have to initially we have to check whether the matrix is balanced or unbalanced one. So balanced or unbalanced one is nothing but that now supply that requirement and needed and requirement and demand should be same. So here I have chosen one problem, that is we are going to find out the IBFSC through northwest corner method. See the table, this is the transportation table. So in that we have listed here PQR as a columns and ABCD are as a rows. So at the end of the rows we have listed some values 7, 10, 9, 16, which is our supply. So at the last in the end of the column we have listed some values 7, 10, 9, 16, which is named as supply, and the end of the row we have some values which is 9, 13, 20, which is our demand. So to apply the transportation to apply any one of the method to find IBFSC, that supply should be equal to demand. Here values are same, that is each equal to 42, and in between the cell values denoted the transportation cost. So that is we are transport that items from A to B, that traveling cost is 4. Similarly the items transport from A to Q, the traveling cost is 9. So like that the table is constructed here. So we are going to get that we are going to find out the IBFSC solution for this table through northwest corner method. Let's see how to find out the solution through that procedure. First step, initially we have to check whether that given transportation matrix is balanced or not. Here given is balanced one because the demand is equal to supply. So already I discussed with you here demand and the supply is equal to 42. So it's a balanced one. So we are directly started the procedure to find out the IBFSC. So the as per procedure, the first step is First, select the cell located at the northwest corner, that is upper left corner. Here, upper left corner value is 4. Choose that 4 value, that is AP cell value is 4, which is the upper left corner. So, we have assigning the value in that left side, that is after selecting that upper left corner cell value, choose their corresponding row value and column value in that allocation. So which one is the minimum value, we have to fill that in the left corner value. So here the corresponding row value of 4 is 7 and column value is 9, that is demand value is 9, supply value is 7. So that I have chosen among these two as minimum one. So among 9 and 7, 7 is the minimum value. So I selected that 7 as our I have chosen 7 as a location value. It's located in the left corner of this transportation table. So after fixing that 7 as a assigning value, so we have to subtract these two values from their corresponding supply and demand. So after assigning this 7, we get that supply value for the first row as 0 and demand value for the first column as 2, that is 9 minus 7 equal to 2. So by this way, if we are proceeding that procedure only, we can that transportation matrix as balanced one till that end. So we are repeating the process in the same way till the last stage until we are getting that that is 35 as a 0. That is until we are getting the total demand is equal to the total supply. So after assigning 7 as a left corner value, that first row value becomes 0, so that I eliminate the first row. So after that assigning, we get new matrix. So new matrix with the 2 columns, 3 rows. So in the 2 columns, 3 rows, again we have repeated the same procedure. So we are choosing the left corner value of that resulting after step 1 procedure. So that left corner value is 5. That is BP cell value is the left corner value right now. We choose that value as a allocation cell. So their corresponding supply value is 10 and their column value, demand value is 2. So we fixing that minimum value among these two. So 2 is the minimum value. I have chosen that 2 as allocation value. So I fix it as a left corner value. So after fixing that, we have to change supply and demand value. So after fixing 2 in the left corner value, the supply value will be changed as 8 and demand value for the first column will be changed as 0. So we are removing the first column from the transportation matrix. So similarly, we are repeating the process for the next case. After that, we are getting new matrix with 2 columns, 3 rows. So their left corner value is 5. So here we are assigning as a minimum supply value 8, and then after assigning that 8 value, automatically the second column demand value reduced by 5. So we are after getting that second row as 0, we are eliminating that rows 2. So we are repeating the process until our that is demand and supply is equal to 0. So here we stopped all the value. We are stopping our procedure because all demands is satisfied by our supply. So we stop that procedure here. Now we have to consider the matrix. What are the allocations made in that each cells. So now we are going to write the IBFSC, that is minimum transportation cost. It's can be written as the by allocated value in their corresponding transportation cost. So for the first cell, AP cell, so allocating value is 7 and their corresponding transportation cost is 4. So 7 into 4. Next plus, next one, BP, second row, first column value. So our allocated value is 2 and their corresponding transportation cost is 5. So 2 into 5. So similarly, we have to multiply all these remaining 4 allocations. So after that simplification, we get that value as 208. This is our IBFSC value for the given transportation problem. So next method is Vogel approximation method. So VAM. So this is the I have listed here what are the procedure we have to follow that to solve that transportation problem through Vogel approximation method. So this is a different to northwest corner method. So comparatively Vogel method is the best. So among these two methods, the Vogel approximation method is a systematic method and it's required a minimum time to find a solution. This method involves less number of computations. So comparatively, Vogel method is the best one among all three. So this is a procedure. I explained that procedure by solving that problem. So this is the problem I have taken to find the IBFSC through Vogel approximation method. So here I have 4 columns, 3 rows. At the end of column, I have listed the some supply values 50, 60 and 25 and demand in the last column 60, 40, 20 and 15. So as I already told you, to find the transportation method problem, initially we have to check that given matrix whether balanced or not. So for that I am going to add all supply value and all demand values. So here demand is equal to 135, also it will be is equal to supply, so that given one is a balanced transportation problem. So we can apply the Vogel approximation method. So to apply the Vogel approximation method, first we need to calculate penalty of each rows and each columns. After checking whether balanced or not, suppose the given matrix balanced to 1 means we have to make that suppose the given transportation problem is not a balanced one means we have to make that problem as a balanced one by adding either dummy rows or dummy columns with an entry zeros. It's our role. It's our it's our part to make that problem as a balanced one. But here directly they are given a balanced problem one. So we are directly start the procedure. So first step to solve that transportation problem through Vogel method, we need to calculate penalty for each rows and each columns. The formula to find the penalty is equal to second minimum value minus first minimum value for each row and each column. So this is the matrix for constructing penalty value for each step. So here I have 3 rows. For first row it's denoted as A. So in the first row we have 4 entries. Here first we have to select the first minimum, which value is 2. Second minimum value is 3. So that penalty is calculated by the 3 minus 2, that is second minimum minus first minimum. So 3 minus 2 equal to 1. So similarly we have to calculate for each rows and each columns. So after calculating penalty, we have choose the highest penalty value among them. Here I have highest penalty value was 3 in the second column value. So I have highlighted here as a green one. So this is our allocating columns. So after penalty calculating, so we have choose which one is the maximum value among this penalty. So here I have second column as a maximum penalty. So I have chosen that one for assigning, that is for allocation. So after choosing the second column one, we have to consider all the entries. Those entries nothing but transportation cost. So our major goal is we have to minimizing our transportation cost. So among these 3, which one is the minimum cost means, so it's in the first row, second column, that is AQ cell is the minimum cost. So we are making the allocation in the cell. So they are now see the corresponding supply and demand for that particular cell, AQ cell. So here supply is 50 and demand is 40. So we have assigning minimum value of these two. So obviously the minimum value is 40. After assigning 40, the demand column automatically becomes as 0 and the supply row, that is A row, getting 10. So after vanishing that column, we remove that from the transportation table. So we are so next we are moving the second step. So again we are finding the penalty value for remaining rows and columns as we discussed in the previous step. So again I am constructing the penalty values for each rows and columns except the Q column. So my penalties are 3, 1, 2 and column penalties are 1, 2, 2. Among these 6, 3 is the maximum value. So I have chosen that first row for allocating 1. So in the first row we have 3 cost 3, 7, 6. Among these 3 is the minimum cost. So I have made a allocation in the AP cell. So the cost, their corresponding supply row value is 10 now. Their corresponding column value is 60. So among these two, 10 is the minimum value. So I have filled as a allocation value. So after allocating, so the first row becomes 0 as a supply value and first columns is changed as 50. So which the 0 rows we are eliminating from the transportation table, and we are now moving to the next step, that is we are repeating the same procedure. So in the same way we are repeating the all procedure. So after the third step we are getting our third row will be getting eliminated. So again I am repeating the same procedure. So I repeatedly I have applied that procedure as we discussed in the previous case. So I finally I have get that transportation table like that only. So I stop here because I my supply and demand get balanced, that is all balance get 0. So I stop the procedure. Now I am seeing what are the allocation I have made so far. These are my allocation, that is for in the first row first column, that is AP cell allocated by 10 and AQ cell allocated by 40, BP cell allocated by 25 and BR allocated by 20, BS allocated by 15, CP allocated by 25, CQ not allocated. These are the allocation, that is totally we have made 6 allocations. After we are finding the IBFS, so it's calculated by multiplying each allocation value with the air transportation cost and add all those 6 allocation value. So after simplification we get 420 as a minimum transportation cost. So this is the method to find the transportation problem through Vogel approximation method. I hope you all understand what I have explained in the both the method. So it's we are finding only IBFSC value, that is initial basic feasible solution only we have calculated, not an optimum value, because optimum value is our major major role, because we have to minimizing the transportation is just we are making some solution relevantly to our transportation matrix. So we have to again we have to apply that solution. We have to move on to find the optimum solution. We will discuss in the next class. Thank you all.